Hello friends, welcome back. In this video, we will discuss how VXLAN EVPN works on Arista EOS using static floodlist, and we will also check how head-end replication works, how to configure static floodlist, and what to verify on Arista EOS when bridging bump traffic without BGP EVPN. And in the following sessions, we will go over the BGP EVPN flavor of running VXLAN on Arista EOS. So I suggest you to watch this video till the end. So what exactly is static flood list and what does it do? So first of all, the VTEPs need to know each other in order to send unknown traffic like ARP requests to learn the attached MAC address on those segments. So from a design point of view, we have a couple of different options, namely statically defining the remote VTEPs or the loopback IPs of all the remote VXLAN tunnel endpoints or VTEPs, which is what we will discuss in this session, or we could dynamically advertise them into BGP up to the spines and then have the spines reflect or replicate them to the remote leaves. That's when the spines operate as root reflectors. That will be discussed in the next session. So with static flood lists, instead of learning the remote destinations from a control plane protocol such as BGP EVPN, we configure a static flood lists under the VXLAN interface, and we define the list of remote VTEPs that we need to send the bump traffic to. So for example, if we receive an ARP request, we will define the remote VTEPs to which the ARP requests will be sent to. So the local VTEP will create a unicast UDP packet towards those remote VTEPs, and that's what we will be configuring in our lab as well. So let's have a quick discussion on how head-end replication works in case of VXLAN static flood lists. So from a traffic point of view, the source sends an ARP request. The local VTEP, which has the VLANs mapped to a VNI or VXLAN network identifier, it will generate broadcast or unknown traffic. And the local VTEP will then create a separate unicast VXLAN packet towards every remote VTEP in the configured flood list. And the flood list is something that we configure statically under the VXLAN tunnel interface, hence the term static flood lists. Each packet is sent over port 4789, allowing the remote VTEP to bridge the frame and learn MAC reachability. So that's what we call as head-end replication. So it's the responsibility of the ingress VTEP to replicate the unicast, broadcast, or unknown traffic that it receives from its local endpoint to the list of all the remote VTEPs that it has configured statically under the VXLAN tunnel interface. And the port it uses for this purpose is UDP port 4789, and the traffic that gets sent towards the remote VTEPs is the broadcast, unknown unicast, and multicast traffic, hence the term bump traffic. The advantage of defining static flood lists under the VXLAN tunnel interface is that it's simple to understand for small labs or POC purposes, and there is not much moving pieces to configuring a static flood list. So static flood lists are comparatively simpler in terms of design as compared to BGP EVPN, where we dynamically advertise VTEP addresses into BGP. So the trade-off here is that static flood lists require manual addition or removal of VTEPs when we add or remove VTEPs into our VXLAN domain. It has its scaling limitation, and it does have replication overhead in large fabrics. So the switches will have to send an individual copy of the ARP request to each of the remote VTEPs that we have manually defined in the flood lists. So for example, if we have 50 leaves in the fabric, the local switch or the local VTEP will have to make 49 copies of the op request and send it to the remote VTEPs defined in the flood list. And if we add a new VTEP, that needs to be updated in each of the other VTEPs which has the VLAN to VNI mapping configured. So it does add both in terms of configuration and operational overhead. And in terms of configuration, static flood list is much easier as compared to BGP EVPN. So we define the VXLAN interface, and then we also define the source of the VXLAN tunnel interface, which in our example is loopback 0. The default UDP port is 4789, so this is optional. And then we define the VLAN to VNI mapping. So in our example, we will be creating VLAN 10 and mapping it to VNI 100,010. And then we define the flood list using the VXLAN flood VTEP command. And then we specify the IP addresses of the remote VTEPs that we want to send the unknown traffic towards. And anytime if we need to add another VTEP to the list, we must ensure that we add the keyword add. It's very similar to switchboard trunk allowed VLAN add, and then we add the VLAN ID. Similarly, when we need to add a VTEP to the flood list, we need to ensure that we add the add keyword. Otherwise, the existing VTEPs will be overwritten. And the key components of the configuration above are the loopback 0 interface or whichever source interface you would be using for the VXLAN tunnel interface, and then the optional UDP port command. Then we have the VLAN to VNI mapping, which must match on the participating leaf switches. So in our example, we will be configuring our leaf switches to use VLAN 10, which will be layer 2 switching. So having said that, let's go to our lab and then we will configure the VXLAN tunnel interface and go over the remaining configuration step by step. So for our lab, like we see, we have 6 Arista switches, Arista 1 through 6, where Arista 1, 2, 3, and 4, they are our leaf switches, and Arista 5 and 6, they are our spine switches. And they are configured, or let's say they will be configured as root reflectors going forward when we go over the BGP EVPN flavor of VXLAN. And in our topology, Arista 1 and 2 are configured in an MLAG pair, so they are running MLAG. The loopback IP of the Aristas are 10.0.0.1 for Arista 1 and going up to 10.0.0.6 for Arista 6. And then we have switch 1, switch 2, and switch 3 configured as host or client devices. And we will be using these devices to ping or test reachability between each other. So in our topology, we have OSPF as the underlay routing protocol. So to ensure loopback to loopback reachability between Arista 1 and Arista 4, or let's say between all the Aristas, we will be using OSPF as the underlay routing protocol. So I've already configured OSPF in the underlay. So like we see, Arista 1 has an OSPF neighborship with the 2 spines, Arista 5 and Arista 6 on interface Ethernet 1 and Ethernet 2 respectively. And it is learning all the OSPF routes. So let's say if we ping 10.0.0.0.4, which is the loopback IP of Arista 4, sourcing from the local loopback IP, which is 10.0.0.1, we see that we do have reachability, and we see that the remote loopbacks are all reachable via both Ethernet 1 and Ethernet 2, so they are getting load balanced between the 2 spines. So let's configure the VXLAN tunnel interface starting with Arista 1. So let's go to the global configuration mode and then let's go to the interface VXLAN 1 config. So if we do a show active, we see that the VXLAN UDP port is 4789. So that's the default config or the default port number for VXLAN tunnel interface. And then we will specify the VXLAN source interface, which in our case is loopback 0 for all the VTEPs. And then we will specify the VXLAN VLAN to VNI mapping. So in our example, we are using VLAN 10, and then we will map it to VNI 100,010. And finally, we will define the static flood list using the VXLAN flood VTEP command, and then we will specify the IP addresses of the remote VTEPs that we want to send the broadcast, unknown unicast, and multicast traffic towards. So we are on Arista 1 right now, so we will define Arista 2, Arista 3, and Arista 4 under the flood lists. And like we discussed previously, anytime if we need to add or remove a VTEP from the flood list, we need to use the same command but with the add or remove keyword. So let's say if we try to update the flood list without the add keyword, let's do a 5, and now let's do a show run interface VXLAN 1. We see that we have overwritten the existing flood list. So anytime that we need to update the flood list, it is important that we use the add or remove keyword. So let's re-add the loopback IPs for Arista 2, 3, and 4. So that's done. Let's do a verification. So we see that we have the loopback IPs of Arista 2, 3, and 4 under the interface VXLAN 1. So we can copy and paste pretty much the same config on the other VTEPs. So let's go to Arista 2, paste, and we just need to update the flood list. So instead of 10002, we will replace it with 10001 for Arista 1. And let's now go to Arista 3. So we have interface VXLAN 1. So we will say Arista 1, 2, and 4. Let's now go to Arista 4. So we say interface VXLAN 1, 1, 2, and 3. And then we save the config. So friends, in our topology, like we discussed earlier, we have Arista 1 and Arista 2 configured in an MLAG pair, and both Arista 1 and Arista 2 has an interface ETH3 connected to switch 1 on interface ETH1/1 and ETH1/2 respectively, and these two ports are configured as PO1 from switch 1's perspective, and on Arista both these ports are part of port channel 10, which is MLAG 10. So let's have a look at the CLI. So let's go to switch 2, which is a single attached host connected to Arista 3, and we will ping between switch 1, which is 192.168.10.10, and switch 2, which is 192.168.10.20. So let's go to switch 2. Like we see, we have the SVI created for VLAN 10 with an IP of 192.168.10.20. And on Arista 3, we have the interface VLAN 10 created with an IP of 192.168.10.3/24. We also have the IP virtual root address of 192.168.10.254 and the virtual MAC address with the value that you see on the screen. So friends, let's check the connectivity between the end devices. So we will ping between switch 2, which has an IP of 192.168.10.20, and switch 1, which has an IP of 192.168.10.10. But before that, let's do a quick ping between switch 2 and its directly connected leaf switch, which is Arista 3. And on Arista 3, we have an SVI for VLAN 10, which has an IP of 192.168.10.3, and it also has the same virtual router address configured that we saw earlier on Arista 1 and Arista 2. So this is to make sure that if there is any workload mobility between these Arista switches, then the default gateway would remain the same, and also the MAC address would remain the same, as these Aristas are configured for a unique virtual MAC address, and that's the MAC address with the value that you see on the screen. So let's go back to switch 2 and ping between switch 2 and Arista 3. So let's do ping 192.168.10.3. So yeah, it can ping Arista 3. Yep, and it can also ping 192.168.10.254. So that's the unicast gateway that we configured on Arista 3. Let's check the ARP entries on switch 2. So for 192.168.10.254, we see that the ARP entry is the one that we have manually configured on Arista 3. So yeah, let's now ping between switch 2 and switch 1. So like we saw earlier, switch 1 has an SVI configured for VLAN 10, and it has an IP of 192.168.10.10, and the SVI status is now up. So let's ping between switch 1 and switch 2, but before that, let's ping from switch 1 to its local uplinks, or its local upstream devices, which are Arista 1 and Arista 2. So on switch 1, let's ping 192.168.10.1, which is Arista 1. So let's confirm that. Show run interface VLAN 10. Yep, that's 192.168.10.1 with the virtual root address of 192.168.10.254. And on Arista 2, the VLAN 10 IP is 192.168.10.2 with the same virtual root address. So yeah, we can ping between switch 1 and Arista 1. Let's do the same for Arista 2. So yeah, there is reachability between switch 1 and the two Arista switches to the north of it. So let's ping between switch 1 and switch 2. So yeah, that's the final verification. So switch 1 can now ping switch 2, and that is across the Arista fabric. So traffic will be hashed to either Arista 1 and Arista 2, and then it will get load balanced between Arista 5 and Arista 6 before going to Arista 3. So let's do some verifications on Arista 1. So let's check the VXLAN address table. So Arista 1 is learning the MAC address for the SVI on switch 2 via the VTEP address 10003, which is Arista 3. And let's verify the MAC address for the SVI on switch 2. So we go show interface VLAN 10. So that's the value we see for the SVI on switch 2. And that's exactly what we learn on Arista 1. And if we check the VXLAN VTEPs, so it has learned about 10.0.0.2, 0.0.3, and 0.0.4. So that's the manual flood list that we configured under the VXLAN tunnel interface. So you can also do a show VXLAN flood VTEP, and it will show us the mapping according to the VLAN. So for VLAN 10, we are using 10.0.0.2, 10.0.0.3, and 10.0.0.4 as the static flood list. And likewise, we can do the same verification on Arista 2. So let's say if we do a show VXLAN address table, it's learning the same MAC address from VTEP 10.0.0.3, which is Arista 3. So before we wrap up this video, let's do a quick capture a data plane packet and then try and break it down. So friends, this was a capture of an ICMP request sent by switch 2 to switch 1. So we see that the source is 192.168.10.20 and the destination is 192.168.10.10. So the ICMP packet gets encapsulated in the VXLAN header, and we see that the VNI that we have here is 100,010, and that's the VLAN to VNI mapping that we have configured under the VXLAN tunnel interface on all the participating Arista switches. And the outer IP header has the source of the VXLAN tunnel interface on Arista 3, which is 10.0.0.3, and it has the destination of Arista 1, which is 10.0.0.1. So let's say if we verify that on Arista 3, so let's say if we do a show VXLAN address table, we see that we are learning the MAC address for the SVI on switch 1 via Arista 2. But again, the traffic could be load balanced between 10.0.0.1 and 10.0.0.2, as these switches are in a MLAC pair. So if we do a show interface VLAN 10, so that's the MAC address for the SVI. And let's see if we go back to Arista 3 and check the VXLAN address table. So that's the MAC address we see on switch 1. So friends, this was a detailed overview of how VXLAN static flood list works on Arista EOS platform. And in the upcoming video, we will go over the BGP flavor of understanding and configuring VXLAN BGP EVPN on Arista devices. So friends, thank you very much for your time today. I hope you liked the content of this video, and if you did like it, please give it a thumbs up. And if you haven't subscribed to my channel yet, please hit the subscribe button. Please feel free to leave a comment in the comment section, and I'll catch you in the next video. Thank you very much.